anyone? Okay, I think we've got most everyone here. Let's get started because we've got a little bit to cover. And I want you to have time to work on projects for the last half of class. All right, so today we have a warm-up. We will look at that in a moment. We are also, there's what I'm looking for. Going to be looking at our last two core technologies, all right? So amazingly, we've made it all the way through. So this is the last project, and it is going to be on optical and thermal technology. So first off, the vocabulary quiz will be due next Tuesday, right? Today's Friday. Vocab quiz for optical technology and thermal technology will be due next Tuesday. I am trying to get the project into the next quarter. So ideally that will be due on Tuesday, the 2nd or 3rd of February. The quarter ends, just for fun, that's going to be the second Groundhog Day, okay? Canvas won't let me put an assignment in this quarter that's due next quarter. So just know that your projects are due in the next quarter, all right? We're going to look at a couple of videos for optical and thermal technology to give you an idea what they are about, what kinds of careers are in these fields, and what kind of cool developments are coming down the track. There's a very cool piece about shrinking a telescope. This looks like brand new technology that is really going to be revolutionary. So I'm very interested. Let's look at our warm-up. Okay, I have it set so I can preview. All right. So which technology was this example used for? Was it electronic, mechanical, structural, or thermal? I apologize. I did not correct my spelling since last class. Anybody have an idea? You can put it in the chat or sing out, or I can get the fabulous spinner of death working. Nobody's died yet from getting
maybe mechanical.
Mechanical, perfect. You are brilliant. So the reason that it is mechanical is it is made out of mechanical devices and creates motion. It's the tongue of the latch is moving backwards and forwards when you turn the knob. That is mechanical technology. I didn't want to put material in because almost anything qualifies as material. Okay, how about this one? Which technology was this an example of? Is this mechanical, biotech, fluid, or optical technology? We need someone new. Someone be brave. Nelson, can you tell me? Nelson Ramos?
Somebody put it in the chat.
Okay. Joey did. Good job, Joey. Yes, biotech. This is the idea that you can make drugs out of plant material. The Amazon is a very precious resource, that there are plants and animals and systems there that no one has ever seen or understood, and a lot of them have medicinal properties. So there's a whole division of biotechnology and pharmacology, really, the pharmacy, that looks into exotic plants and animals for sources of drugs. Okay, things like curare were found from looking at indigenous tribes. Curare is a poison that paralyzes you. You don't die, but you're paralyzed. So they use that on their arrows. Okay, number 3. Which technology is this an example of? And I am looking at it as a house. Okay, is this mechanical, fluid, structural, or optical technology?
Is it structural?
Everybody says structural. All right. Well, I am so proud that we all know our core technologies. I know we've spent a fair amount of time on this, but they are so pervasive and they are so tied to, interesting careers, interesting ways of creating stuff and participating in your world. For me, when I look at a job that I want to do, typically this is a line that I got from my fourth grade art teacher. I want it to have some social redeeming value. I want what I'm doing to make a difference to someone, to somehow change someone's life, change their opinion, make them a more educated person. That makes me feel like I'm contributing something to the world, not just myself. So take a look at these videos. Think about some of the things we're talking about. Okay? So let's get back into our module. Great job, team. Let's look at our presentation. As usual, we are just going to breeze through. Where was the one that I did? This one. This is a fun one, just in that the driving question. What is it that you need to know about the core technologies to be academically successful in this course? You need to be able to locate a core technology in a technological system and justify that it is correctly identified as a particular core technology. I'm having a little trouble with some of the projects. People are describing the technology perfectly. They are saying what it does, but they are not validating it in terms of, as a result of it heating up with electrical coils and being plugged into the wall, that makes it electronic technology. Their descriptions are perfect, but it's sort of, thus this is electronic technology, needs to be on the end, because you have, in theory, you need to be justifying, like in front of a teacher or something, you need to justify why you pointed at the heater as an example of electrical technology. All right. I know that some of my ESOL students, English as a second language, are having trouble with these projects, that there is a lot of explanation and it's a little difficult to understand. So just know you can always reach out to me, but this is the core of what you are trying to do. When you have a slide of a haunted house or a dream house, you're looking for the core technology that we're working on and finding an example of it. You say what it is, and then you say why it is electrical technology, okay? I've got some great projects to look at. Let's get down to where we belong. I think we all know biotech by now. Structural technology is pretty easy. Material, everything's made out of a material. There's my friend Cheyenne. Okay, so Cheyenne, we're just going through the presentation. We went through a little warm up. We are working on optical and thermal technology today. So material technology, I think everyone gets. And the idea, material is easy because everything is made out of a material. All right. Mechanical. Mechanical is a technology system that uses mechanical parts working together to produce, control, and transmit motion. Right? Fluid. A technology system using either gaseous, pneumatics, or liquid, hydraulic, to apply force or transport. That is fluid technology. Remember, gases are fluid technology. Air is fluid technology. Electrical technology. The technology system that produces, stores, controls, and transmits and gets work from higher voltage electrical energy sources. Remember that definition. There is something in our module for today that is very similar. Okay? So electrical, then electronic. So the easy way to spot the difference between electronic and electrical is the voltage. Electronics use low voltage, 1.5 volts, 3 volts, 12 volts, 7 volts. Typically it is DC power too, direct current, as opposed to alternating current. Alternating current is what comes out of the wall. Direct current comes out of a battery. Or you can convert alternating current into direct current. So electronics is a technology system that uses small amounts of electrical energy for controlling, detecting, information collecting, storing, retrieving, processing, and communicating. Okay, that is electronic technology. Now, and what they love to say is, what's the difference between electronic and electrical technology? About 100 volts. Much higher voltage in electrical. Optical. Okay, waves and lights. Why do you think optical is being characterized as waves and lights? I understand the light part, but what's the waves coming from? Anyone?
Maybe like light waves.
Hang on, someone's trying.
Oh, sorry. I said maybe like light waves.
Right, light waves. Light is transmitted in a wave form. Light photons travel in a wave form. Those waves determine the color of the light. Very short waves are ultraviolet light. Long waves, what, red? Is red first on the spectrum? I can't think. But it's the idea that the spectrum of light is based on the period of the waves. When I say period of the waves, a wave goes in a sine curve. It goes up and down and up and down. A wavelength is from the top of one wave to the top of the next wave. That unit is called a wavelength. And the wavelength of light is how they describe colors. Okay? Optical technology. Optical technology is a technology system that produces light, controls light, uses light for information collection, processing, storage, retrieval, and communication, and the using of light to do work. What does that sound very similar to? There was a technology I just read that was very similar in the description. Does anyone remember? It's electronic. Electronic technology, if I go back, it is for controlling, detecting, uses small amounts of electrical energy for controlling, detecting, and information collecting, storing, retrieving, processing, and communicating. Let's see what optical does. It uses light for information collection, processing, storage, retrieval, and communication. How are optics and electrons both able to do the exact same job? It seems strange that these are two very different technologies. One is using electrons, one is using light photons, but they can both perform the same duties. That is because light can be used like an electron. Light comes in discrete packages. They are called a photon, P-H-O-T-O-N. Photons can register the same way that an electron does. So you can use light to create storage, and that would be fiber optics. So that is what fiber optics is. All right, applications of optical technology are the light bulb, the LED, the light emitting diode, lenses to magnify and reduce, laser, speed detector, laser compact disc, fiber optic telephone, communication, laser cutting tools, laser surgery instruments, basically anything with a laser, since it's light emitting. There's also barcode readers, telescopes. We are going to see a very cool thing about reducing the size of telescopes in a minute. Okay, so glasses. I'm guessing this is the light on the book. Cameras, optics, lenses, focus. A mirror is optical technology. A laser pointer, don't point it at airplanes. A barcode reader. These are all optical technology. I was saying when I was little, like in the 70s, the only thing we had fiber optics for was they'd make a little palm tree and have a little light, a colored light spinning under it, and it would make it all different colors, and they wave. But these days they use, fiber optics for communications. It's ultra fast. A light photon is much faster than an electron. Okay? I'm not really sure why the signs are here, other than they are visual. But I also think they are all coated with reflective coatings to make them show up in the dark. The lens of a car headlight, optical technology. All right, thermal technology, controlling temperatures, hot to hotter, cold to colder. It is to enhance our ability to make things hot or cold, right? Thermal technology. Thermal technology is a technology system of producing, storing, controlling, transmitting, and getting work from heat energy, okay? Thermal technology is a technology system of producing, storing, controlling, transmitting, and getting work from heat energy. Applications, the furnace in your home, a hot water heater, a toaster, insulation, heat exchanger, radiator, condenser. Refrigerator, car engine. Not quite sure why a car engine is other than it gets hot. Okay, so here's our hot water heater. Here is a weird pool with a solar heater. See, this is a pump. They have a hose coming out into this section. The water goes back and forth slowly. This is black, so out in the full sun, it really heats up and it will warm the water in here, and then it gets pumped back in the pool. This is the furnace. This is a hot water heater, refrigerator, thermal technology. It is insulated. Toaster, electronic technology, or actually electrical technology, right? Because it's heater coils, but it is also thermal technology. It works generating heat. Hot air balloon. This is a radiator in your car. The way it works, there is a thermostat. This is where the hot water from your engine, so the cold water comes off the bottom of the radiator. Cold water is pumped into your engine. It is heated up by the heat of the engine, and then a thermostat tells whether the fan should start blowing on the radiator. The radiator is a series of small pipes, and cool air is going to be blown over them to dissipate the heat in the liquid, your antifreeze. Then as the liquid cools, it descends and goes back into the system. Is this a closed or an open loop system? Your car radiator. There's one thing in here that tells you which system it is. It's the feedback mechanism. Can anyone see the feedback mechanism in this system? And what does a system with a feedback mechanism, what kind of a system is that? You can put it in the chat or you can sing out. What kind of system has a feedback mechanism? Remember, monitoring the output to control the input? Nobody? Come on, guys. I got a bunch of nice projects on this. When you have feedback in a system, it is a closed loop system, right? Feedback is what is monitoring the output and adjusting the input. So what is happening is the thermostat has a thermometer in it, just like your home. When the water coming out of the cooling system of your car is hot enough, the thermostat will tell the fan to turn on so that the fan will blow across the coils, cooling them. All right, that is it. Let's get back into, so remember everyone, every single time, our words are inside the parentheses here in the assignment. Do not give me other words. Do not give me core technology. I want optical technology and thermal technology. When the words are right on top of the assignment, it makes it very hard for me to give you credit if you're giving me the wrong words, okay? Let's look at some videos. We are just perfect. Okay, shrinking the telescope. I'm only going to look at the first minute of this, but this is a technology, a brand new technology that I had never heard of. Very cool optical technology. You seeing and hearing it all?
As biological beings, what we do is we collect light and then
Yeah, we
re-image
can hear
that light using some sort of optical system, a lens like is in your eye or a telescope. That's certainly the simplest way to form an image, but it involves bulk optics for transporting the light and moving it around to form the image. And when the size of that aperture starts to get large, that completely dominates the sensor in terms of its size and weight, how much power it consumes. And there's a huge cost associated with that increase in size, weight, and power. Spider is a new way of collecting light to form images. So interferometry is just a way of doing it. It's a way of taking light that's collected at two different places and combining it directly, interfering it, and it forms what are called interference fringes. Much like, if you have two waves in a lake that are interfering with each other and overlapping and forming these standing waves that you might have seen. So we collect the light, couple it into this silicon chip, move it around and combine it in a way that we can measure it with just ordinary detectors like you would have in your cell phone camera. And then take all of that data that's collected by those detectors, process it in a computer, and form it. It's just a simple disk, and the disk itself is just made of silicon chips, very thin chips. And so it only scales in 2 dimensions. To have the same performance as the telescope behind me would have to have the same diameter, 1 meter diameter, but the thickness would stay the same.
We do all the operations on the light in the circuit instead of bouncing back and forth between mirrors. So it's just a way to shrink everything into a much smaller and lighter package.
For the Spider program, we're partnering with the...
Giving up on this, I don't think we need to read the program. So how about that? The idea that now you can make a 1 meter telescope, a 1 meter telescope, and it will be a disc this big around and that thick, about 3/4 of an inch, 1 inch thick. That's incredible. That is so cool. And I don't know if you noticed, one thing to show you is, I'm not sure how the interferometry works, but see right here, what they're doing here, they are using stereo imagery so that there is depth in it actually with this collection. You have 2 different sensors. They're pretty close together, but they are still stereo. Their inputs are coming down together, and as you see, this unit and the next unit are being linked together, and their signals are being cleaned up to provide this clear picture. Very impressive. All right. Okay, so let's look at lowering the cost of concentrating solar energy. I think this is pretty cool. This has both of our technologies in it.
Okay, take the natural heat from the sun, reflect it against a mirror. Focus all of that heat on one area, send it through a power system, and you've got a renewable way of making electricity. It's called concentrating solar power, or CSP. Now, there are many types of CSP technologies: towers, dishes, linear mirrors, and troughs. Okay, have a look at this parabolic trough system. Parabolic troughs are large mirrors shaped like a giant U. These troughs are connected together in long lines and will track the sun throughout the day. When the sun's heat is reflected off the mirror, the curved shape sends most of that reflected heat onto a receiver. The receiver tube is filled with a fluid. It could be oil, molten salt, something that holds the heat well. Basically, this super hot liquid heats water in this thing called a heat exchanger, and the water turns to steam. Now the steam is sent off to a turbine, and from there, it's business as usual inside a power plant. A steam turbine spins a generator, and the generator makes electricity. Once the fluid transfers its heat, it's recycled and used over and over. And the steam is also cooled, condensed, and recycled again and again. One big advantage of these trough systems is that the heated fluid can be stored and used later to keep making electricity when the sun isn't shining. Sunny skies and hot temperatures make the Southwest U.S. an ideal place for these kinds of power plants. Many concentrated solar power plants could be built within the next several years, and a single plant can generate 250 megawatts or more, which is enough to power about 90,000 homes. That's a lot of electricity to meet America's power needs.
Okay, I just wanted to ask a couple quick questions. Hang on. Where is mine?
One big advantage of these trough systems: parabolic troughs are large mirrors shaped like a giant U. Large mirrors shaped like a giant.
Okay, so what technology are the parabolic troughs? What technology are the parabolic troughs we're looking at? Are they going to be thermal or optical? Come on, team. This isn't that tough.
Maybe optical.
What's that?
Optical.
Optical, exactly. What I was saying, the reason I'm going through this is these systems are really exhibiting both technologies. So the parabolic mirror is optical technology because it is reflecting photons. But what is the receiver? What is this pipe that goes down the center of this trough and that the light is being focused on? What technology would the receiver be?
Thermal.
What's that? Thermal. Right.
Yeah.
And again, I just wanted to highlight this amorphousness. I would guess that technically it is also optical technology because light is being used to heat, to cause the thermal reaction, right? So anything that light is being used to heat is optical, but once you're heating, then you're into thermal, okay? I just thought that was interesting in these. Last one coming up. Okay. Thermal energy storage. Okay, this one doesn't have any sound to it, so I'm going to read this out because I think it helps. This is from the Argonne National Lab. I don't know if you know, we have about 4 or 5, there are probably more, national labs that do things. So Los Alamos is a national lab. Scandia is a national lab. It's not Chapel Hill, but there's something down in North Carolina that's a national lab. These are where real great science is being done. This is an amazing technology that I have never seen before. It's the idea that they have created a battery that can store heat very quickly and that they use it in conjunction with other systems like power generation or you know, giant fans or whatever, that those systems are not 100% efficient, right? When people talk about the efficiency, it is, you can tell how much energy is in a gallon of gas. There are scientific ways of doing that. And you can measure how much energy you are getting out of your system if you burn that gallon of gas. You're never going to get all the energy that is in the gallon out of an engine working. When an engine works, remember, you know, why we're cooling our engine. Not only is it delivering torque to your drivetrain, it is generating heat. You don't want the heat. You don't care that it's incredibly hot under your car hood. But with the advent of these batteries, you could be capturing that heat and using it for another purpose, thus increasing the efficiency of your car using the gasoline. You are getting more energy out of the gasoline by capturing the waste heat with these batteries. All right, I think this is very cool and fun. Many processes that generate power also produce heat, a source of energy that often goes untapped. Engineers at the US Department of Energy's Argonne National Lab have developed a technology to capture and store this wasted heat. Argonne's thermal energy storage system, TESS, is a new kind of thermal battery that is both quick and efficient. TESS originally was developed to capture and store surplus heat from concentrated solar power facilities. However, TESS can greatly increase energy efficiency and cost effectiveness of many industrial processes. Unlike other thermal batteries, which take a long time to charge, TESS rapidly stores heat and releases it. The size of a garbage can, TESS can be scaled down or by choosing the number of units to meet the needs of your thing. These include combined heat and power systems, power plants, heavy-duty trucks, building heating and cooling, thermal desalination plants. Okay, that's it. Learn how to harness heat and power. Just talk to the Argonne National Lab from the Department of Energy. Why am I not? Okay.
Grammarly.
No, we are not listening to another one. And that is pretty much it. Okay, so now we're going to work on projects. And I am up for helping anyone with anything. All right. So I hate to say, for some reason, the 4E project has a bad sheet in it and I need to redo it. So you can look at the 4D assignment down here if you need to be reminded what the pieces are of your haunted house or dream house. Okay. Right here, it shows you that 4A is core technologies and biotech. B is structural technology and material. C is mechanical and fluid. D is electrical and electronic. And E is optical and technology. You are building your slide with a title slide, haunted or dream house of technology, the unit number, 4A, 4B, 4C, and your name. Then you have a slide with the 9 core technologies, okay? Those are in there. I've got the technologies. So if you use one slide for each, those 2 are going to be the top of every single project you do. That is not going to change. What will change is the next slide. Slide 3, place on it the core technology of focus and then define it, right? So biotechnology, studying and modification of living matter. Then we have our 5 examples. If you can cleanly show me 2 or 3 examples on one slide, that is fine. I just don't want you to get too crowded. And I like the stories that you put along with your dream house and haunted house. I like the description. I think that is getting you thinking. I think it is getting you creating. It makes me happy. Some of it is pretty crazy too. Wait till you see the haunted hairdryer. So that's it. If it's a 2-part project, which all of ours are now, once you finish the 5 slides, you're going to have another title card of the next technology, structural technology, and 5 more examples. Then we get your annotations. If you have dreamed up everything in your haunted house out of your head, you can just say, credit your imagination. Okay, I don't want to just drone on. I know I talk way too much. Does anyone have a particular problem or something that they would like to look at? I can go in a breakout room with you. I know people are embarrassed to be asking for help, particularly in front of your friends, but don't fail for embarrassment. I want everyone to pass, and I am here to help you, okay?
Which projects are going to be due on this quarter?
4A through D, okay? So the first one is 4A. It's just biotechnology, right? You have your haunted house, and all you're looking at in your haunted house is biotech. That is why it is 20 points. 4B, structural technology and material technology. That is a really easy one to do for anyone who has not done a project. Structural technology and material technology in a house. Come on, guys. You can find 5 examples in your sleep. All right. I am not expecting these all to be beautiful, perfect presentations. A lot of the ones I show are very beautiful and well done. I will show some of the ones that aren't quite as well done. But I am expecting you to work at your level. We have 9th graders through 12th graders. We have people who are struggling to understand the directions. Just do your best and I will appreciate it. Trust me. Okay? So we have 4. We have 3 40-point projects. Structural and material technology, 40 points. That will get you close to passing. Mechanical and fluid technology, 40 points. Electrical and electronic technology, 40 points. So optical and thermal technology is going to go into the next semester and we'll deal with it from there. I just don't want to try and squeeze that in this last time. I'd rather have more time for you guys to work on your projects, catch up on anything that you've been missing, that kind of thing. I want everyone passing. Trust me, MCPS wants everyone passing. Okay. I think what helps, I mean, let me look at a couple let me just go through a couple presentations from the last project, okay?
Sorry, can I ask another question?
Absolutely. I would much rather have your questions than my thoughts.
If we turn something in late, do you want us to email you and let you know we turned it in, or will you see it?
That is not a problem. As long as things are going into Canvas, Canvas lets me see what has been turned in late. My problem with my other class, with my AP Computer Science Principles, is code.org. I have no way to see when people turn things in. So then I need people to tell me so I can go look. In our grading system, when I go into a category, it shows me anyone who has submitted a project. So if you turn it in late, it just pops up so that I'll see it. And trust me, I'm trying to go through every single column and make sure that I've graded everything. Also,
okay, thank you.
I do count on you guys to understand your grade better than I do. I have 170 students, so I'm going to do my best to make sure that all our grades are recorded accurately, that I am accounting for everything. But I in particular have had some real issues between Canvas, which is my MCPS, and Synergy, which is our grading system of record. That I have, for the moment, I put everything in Canvas and then it gets transferred. And sometimes things don't seem to go where they're supposed to, or that the thing's not syncing. So you know much better than I do your individual grade. I'm going to do my best to make sure that everything is perfect. But if you see something that looks questionable in your grade or on a project, just ask me and I'll take a look and we'll figure it out right away. But that really helps me to catch these little things, because I just cannot go back through 170 students' grades with a fine-tooth comb. My comb's a little bigger. So I'm just counting on you guys to know where you're at. And if something seems weird, and it has been in the past, you're not imagining things. We will get it straightened out, okay? So what I'm gonna do to start with, unless anybody else comes up with a better idea, is let me just present a couple of these pieces that we've been getting. Why, look, this could be my backdrop. This is one of my cousin's photos. Eggs and white radish. Ah, here we go. Okay, so let me switch my sharing. Make sure that you are seeing what I am showing. All right, so here we have Haunted Mansion, Core Technologies, Unit 4D. Beautiful. Technically, these should be, and I didn't really realize this at the start, they should be a haunted mansion of technology or a dream house of technology. Because ideally, once we get those last ones, we can just put all our pieces together into one giant presentation, which will be showing your haunted house with all 9 core technologies identified, or your dream mansion with all 9 core technologies identified. 5 examples. I think that's a pretty impressive accomplishment. So I'm very proud of you. Okay, so this slide and our next one, the 9 core technologies, are going to be the same. There's a problem with this slide. It looks good, it reads well, but we're missing the half of the 8th and all of the 9th technology. So my advice would be reduce the font a teeny bit and see if you can get them all on the slide. So electrical technology. So these are the first 2 slides. She is going to be using these on every single project, right? Cover slide, 9 core technologies. Then we get our title slide of the technology we're focusing on. Electrical technology, getting work from electrical energy, as well as producing, storing, controlling, and transmitting it. Example, a power plant. I like the idea of a nuclear power plant in my haunted house. Any good mad scientist needs an unlimited reserve of power. Anyone who's watched Dexter's Lab knows that. All right, the light switch. Perfect for electrical technology. There's only one light switch in the entire house. The house is generally very dark, but is only lit by either lamps or candles. But this one light switch is for the hallway on the main floor, since it's kind of tight, narrow. There aren't any windows or lamps or candles to guide the way and see doors or anything. So you need the light switch. All right, so flashlight. If you dare shine this flashlight, it could summon bad spirits. The spirits sense the light and return to the scene. It is very risky and harmful, so don't do it. The haunted hairdryer, my favorite. The haunted hairdryer was first spotted at the scene of a crime. People may think it was used to dry the blood and make it seem like the murder happened a while ago. Others think it was used to warm up the murder weapon and make it easier to kill. Everyone knows a warm knife slips in easier. The answer is unknown, but for today, guesses in the haunted house. But up for guesses in the haunted house today. Okay, these are all beautiful and beautifully described, but it has that problem that I was saying. She is not validating that it is electrical technology. A haunted hairdryer, story, and then hair dryers are examples of electrical technology. We have the wall outlet, which Frankie gets plugged into. So again, she is describing the technologies well. Here's an interesting one. Okay, so a drone in electrical technology. What do we think? Does a drone belong in electrical technology? What technology is a drone? Somebody? Oh, we're going to get out the spinner of death. You've all got me muted. I don't think On's here today. Dina, I get to pick on you. Dina, can you tell me what technology is a drone? Does a drone represent? Dina? All right, well, we seem to be pulling teeth here. It is electrical. Now, if you look at it, it is also optical because there's a camera under that drone. If the drone was plugged into the wall charging, then it would be electrical. But I think this was a bad choice for an example of electrical technology. And again, she doesn't validate. Okay, here's some sources for that. Then we're getting, I like it if all the sources are at the end, but that's fine. Then the next card, electronic technology with the definition. I love these pictures. Where in the world do they come from? Game over. So videotape recorder, old static radio. The radio is also used for wind noises. The scariest thing is when you can pick up a phone and hear silence or simply breathing. And that's what the radio will project. Oh, now I've done it. The ghost cam. Cam for taking ghost pictures. Oh, I like the gravestone. I was like, why is a gravestone electronic? This gravestone isn't just an ordinary gravestone in the ground. It is an interactive grave. It kind of acts in the same way the radio does, except gravestones is many, except in the gravestone are many haunting spirits, scary ghosts talking about people walking by to the other ghost, saying stuff like, that's the one, get that one. So it's an electronic gravestone. Then we have a talking head. All right, so this one isn't quite perfect, but it's a great job and it's a really nice, clean presentation. And as you can see, lots of space to write her things. That's what happens when we do one example per slide. All right, let me take a look at another one. Ooh, I like this one. If I had a dream house, I'd like my dream house to be in Bora Bora. Okay, we got about 10 minutes left. So here we have the dream house, beautiful title, Unit 4D, student's name, perfect. Here are 9 core technologies, interesting font, nicely readable, very nice. All 9 are on board, great job. Then we get our card, electrical technology and the definition. Okay, example 1, LED pool lights. The first example of electrical technology in my dream house are outside LED lights in my pool. These lights are an example of electrical technology because they use electricity to produce light. Production of light. Wow, look at that pool. All right, so here's 2 examples, okay? Electric stove and the microwave. Another example of electrical technology in my dream house will be an electric stove. I prefer electrical versus gas because they look sleeker on top. Electric stoves are examples of electrical technology because they run by electricity, which converts to heat instead of fire ignition. Also, they are high voltage. Typically, that electric stove would be running off 220 volts, not 1.5 direct current. The third example of electrical technology is a microwave. Microwaves use electricity to power and provide energy, which then is converted to heat, which heats your food. That is why it is electrical technology. Now, what's interesting is microwaves. Does anyone know how microwaves heat your food in terms of thermal technology? Anybody know how microwaves heat food? Microwaves excite water molecules. That is why ideally, if you have microwave proof ceramics or whatever, they will not heat up when you put them in the microwave. What heats up in a microwave are water molecules. That is how it works. It also cooks from the inside out. Ceiling fan and the lighting. I will also have plenty of ceiling fans in my dream house at the beach, because as you know, the beach gets hot, and a fan is an example of electrical technology because it uses electricity directly to produce motion. Okay, lighting, I think we're fine. Electronic technology, here's this slide. A picture helps in there, but it's fine. So flat screen TV. TV is an example of electronic because TVs use electricity to transfer electrons from one source to the TV source's power. It's not the greatest definition, but I'll go with it. The drone. Now we have our drone as an electronic device. And what else? It's also optical. Another electric device I will most definitely have with my dream house will be a drone. Since I will be living in a very gorgeous place, I would love to scout out all the sights above my house and over the ocean water. The cool fact about my drone is that it will be programmed and designed to attach on my house somewhere. So when it's time to go out, I just need to remotely press go and it will detach itself. This is electronic technology because it uses electricity to transfer electrons to create motion, the flying function of the drone. Ooh, there's a picture from her drone. Very nice. Radio. Electronic alarm system. The landline. An antiquated piece of technology. And here's the bibliography. Very nice. See, differences between electrical and electronic devices, Circuit Globe, July 20th, and the thing. Very beautiful. Okay, let me look at this one and see. I think I downloaded another. Okay. Okay, so here's Daniela's. This is another dream house. That's not a pool, it's a giant aquarium filled with bioengineered fish, I know it. Okay, so here's her title card, 9 core technologies, nice. Then we get electrical technology with our definition and examples. So when you press a doorbell button, you complete an electrical circuit that allows household electricity to flow through the doorbell's internal electromagnet. Electric hair dryers work by blowing room temperature air through the vents. The air then passes over nichrome wire coils that heat it. Nichrome would be nickel and chrome put together. It's a materials technology, making it able to blow hair dry with hot air. An electric heater is an electric device that converts electric current into heat. The heating element inside every electrical heater is an electrical resistor and works on the principle of Joule heating. Okay, all these descriptions are great and they are describing electrical technology, but she is never validating her product. She is not saying, thus, this is electrical technology. She does have electrical technology right at the top of each thing, so I'm not going to be overly critical. But ideally, you need to bring it around. So when the switch of a flashlight is pushed on into the on position, it makes contact between 2 contact strips, which begin a flow of electricity powered by the battery. Thus, this is electronic technology, low voltage coming from a battery, direct current, okay? Then we get into electronic, and lo and behold, she's got a nice hoverboard, your flat screen TV, your talking refrigerator, your computer, and a printer. All right, and the works came from her brain. I did ask how the word nichrome got into her brain, because I never knew that the coils in a hairdryer were made of nichrome. Okay, oh, look, here comes the little dog. Okay, is there anything else? Anyone have questions, problems? Do you want me to go over a vocab quiz? Should we take a look at Dina's crazy images? I just don't know where you guys find these all. So this is Dina's haunted house. So I love this. She always sets the stage. For my haunted house, I chose to look in the attic for my next step of examples of the core technologies. Photo credit, bloody disgusting. You think this is Mr. Disgusting here? I don't know. What would it be like to be Mrs. Disgusting? Well, it's a difficult life. But where do you get these cool attic pictures? So electrical technology, this is the definition. There's our slide. So first application, the breaker box, been known to malfunction often, causing people to come to the attic in the first place. Since the attic is full of all sorts of dangerous and scary things, this is certainly not something you want to be fixing in the dark. This is an example of electrical technology because the breaker box is the house's center for all electrical needs and uses large amounts of electricity to charge each room. Okay. Now, the only weird thing about a phone is that phones are actually low voltage. They are not high voltage. Let's see. Nope, that's a crazy thing. This phone does not get plugged into an electrical outlet. And you guys are all too young to know that. These phones just had a phone line. The phone line actually is powered. This is why your phone is usually, well, if you have a hard line, that your hardline phone was usually working if you had a blackout, because phones get power from the phone company, not Pepco. Where do you find weird black and white shots of a high tension tower? If you were looking beyond the attic windows, you would see the large power lines. Rumor has it that lost souls of electricians who died working on these power lines roam the surrounding area looking for work. This is an example of electrical technology because it is a direct source of power, harnessing the large amounts of electrical energy at any given time. Okay, the deathly electrical poles. We are done. It's the weekend for some of us. Thank you so much. Please do vocab quizzes, do projects, get me stuff, get passing, have fun at it, make cool, interesting descriptions, and use weird photos. Okay, you can all go.
Thank you.
I will try my hardest.
Wait, actually, could you kind of go over the difference between electrical and electronic again?
Okay, so the easiest thing to remember for electrical versus electronic is the idea that electrical, if it's a device, is probably plugged into the wall, that they are using 110 volt current. That is what comes out of the wall. Electronics are using electricity to manipulate data and stuff. They are typically powered by DC current, direct current, and they are low voltage. They are run by a battery, which is 1.5 volts. They are run by, a converter. How many adapters do you have? I got like 50. Those are all converting alternating current into direct current at 3 volts, 6 volts, 7 volts. Typically, they don't go much higher than 12 volts. So most electronics are working off low voltage, okay? So if I look at my definitions, hang on, let me just see if I can, I'm gonna do my desktop because it's so messy. Anybody else hang out? Julie, do you have a question? Julie? So here, let's just go over electrical, that's high voltage, the technology of producing, so power generation, batteries, producing, storing, controlling, that is what an electronic motor does. It uses variable amounts of electricity to make it go faster or slower. Also, like a dimmer is electrical transmitting and getting work out of electric energy. So the examples are power plant, power lines, light switch, doorbell, electric motor, batteries, generator, electric heater, extension cords, all electrical technology. They are generating electrons or regulating the flow of electrons. Electronic technology is the technology of using smaller amounts of electricity for controlling, detecting, information collecting, storing, retrieving, processing, and communicating. So that is electronics. Electronics are everything you think of as electronics or a gadget. What are electrical devices are things like angle grinders. Remember, we watched that presentation. Electrical devices tend to be bigger and grosser in terms of like, it's a big frickin' grinder. You're gonna grind on stuff. They are big, heavy things using a lot of electricity. Does that help?
Yeah, that does.
Okay, and you know, another we had, if you want to look in that last module, let's see if I can get out of here. I was going to show you. Oh, this is not the right class. That doesn't help me. Modules. Right here, if you want, look at this video on electronic versus electrical devices. It's not the world's fanciest video, but it also, I mean, yeah, this is only, we can watch it right now. Oh no, this is 4 minutes. But this is the one showing you. So that giant control panel, that's electrical. Light bulbs, electrical. Electric motors, electrical. Alternator in your car, transformers in the power yard, electrical. Big grinders, fan, tube light, grinder, water pump, motors, electrical. While electronics, the devices control the flow of electrons performing a particular task. Soldering iron, electronic device. Well, actually, no, a soldering iron would be an electrical device because it's plugged into the wall and it's just a big resistor. Laptop, electrical, electronic. You know, in power supply, electrical. High voltage is used in the electric field, low voltage in the electronics. Electronics manipulates data. Electronics are electrical is usually using copper and aluminum. That's for wiring. While electronics uses, you know, hang on. Electronics use semiconductors like silicon. Silicon, germanium are used widely, diodes, transistors, MOSFET. They are made of semiconductor material, not just a hunk of copper. Electrical is very big on the copper. Okay?
Okay.
Have a great weekend. Just let me know, you know, shoot me an email if you still have questions.
Okay, thank you.
But you can look at that video, it's right in the module. The problem is, I believe it's in Hindi, but it's great examples.
Thank you.
You bet. Have a great weekend.
You too.